Ever felt like your favorite app loads instantly, while another just bot lags? Or maybe you wondered how massive websites handle millions of users without, breaking a sweat. There's often a secret weapon at play there. Caching. Okay, let's unpack this. For today's deep dive, we're taking on the crucial world of caching tools, specifically Cache, Redis, and Memcached. You've sent us a fantastic stack of sources breaking down what these are, why they're used, their advantages, how they compare, and crucially, how they integrate with Spring Boot applications.
Yeah, and what's fascinating here is how these tools tackle such a fundamental problem in software, speed and efficiency.
Right.
Our mission today, I think, is to help you quickly grasp these essential concepts, understand the nuances, the differences between each tool, and see why choosing the right one can make all the difference in application performance and, well, scalability too. We'll try to simplify the technical jargon and focus on the practical insights you actually need.
Exactly. Before we meet our three main players, though, let's zoom out just a bit. What is caching, like, at its heart?
Okay, imagine keeping your favorite snacks right there in your kitchen drawer instead of, running to the store every single time you want one. That's basically caching. It means storing data your application uses a lot, really frequently, so it can be retrieved super quickly. You're avoiding those slower sources, like hitting a database or calling some external service every time. If we connect this to the bigger picture, caching makes apps faster, obviously. It also reduces the strain on databases, which lets them handle more users without slowing down to a crawl. Cache, Redis, and Memcache are just tools that help implement this caching strategy, each sort of suited for different situations.
Right, so it's all about speed and efficiency, basically making our digital experiences smoother.
Less waiting around. Okay, let's introduce our first contender then. Cache, what is it and what's its claim to fame? So Cache is a tool specifically designed for job applications to store data right in the application so it can be accessed quickly. Think of it like a notepad where you jot down answers to questions you get asked often so you don't have to keep looking them up. It's built specifically for Java programs, yeah. And it can store data either in the computer's memory, the RAM, or interestingly, on a hard drive too. This makes it pretty flexible, for different needs. Maybe you need data temporarily, or maybe you need to save it for longer. Cache is really popular in Java projects, especially those using frameworks like Spring or Hibernate. It just fits right in. And it can work just within a single application, or you can actually configure it to work across multiple computers if you need a bigger distributed system.
Okay, Java-centric flexible storage. Got it. Next up, the one you hear about a lot, the super fast versatile Redis.
Redis. Yeah, it's a super fast tool that stores data in memory. But it's more than just a cache. It can act like a cache, sure, but also as a database or even like a messaging system. It's very versatile. Imagine it as maybe a digital bulletin board where you pin frequently used information user profiles, scores in a game for really quick access. Now, unlike Cache, Redis runs as a separate program, a server, that your application talks to over the network.
Oh, okay, so it's external.
Exactly, and it can handle not just simple data like names or numbers, but also complex data structures, lists, sets, sorted sets, you name it. Rankings, for example. Redis is used by huge companies like Twitter for all sorts of tasks, caching web page data, managing user sessions, tracking real-time analytics. And a key thing, it works with many programming languages, not just Java.
So much broader applicability potentially.
Okay.
Okay, and finally, the lean, mean caching machine, Memcached. What's its story?
Memcached is all about simplicity and speed. It's a high-speed tool for storing data in memory, purely to make web applications faster. Picture it as a quick reference card for data your app needs often, like website content snippets or maybe database query results. Like Redis, it runs as a separate server, but it's designed to be really lightweight, very focused. It only handles basic data key value pairs, essentially like a dictionary. It's widely used in massive websites, think Facebook or YouTube, primarily to reduce the load on their databases. That's its core job. But here's the key point, maybe the defining characteristic. Memcache is great for straightforward tasks, but it doesn't save data to disk. So if the server restarts, poof, all that cache data is gone. It's volatile.
Okay, volatile. That's a crucial distinction.
Yeah.
But each of these tools clearly brings something valuable to the table. Let's delve into the specific advantages of each now, starting back with Cache.
Sure. So each cache advantages. First, speed, especially within a Java app. Because it runs in the same program, the same JVM, access is incredibly fast, no network trip. Second, flexibility in storage. You can choose memory, disk, or a mix. That's quite unique. Third, it's obviously very Java-friendly. It integrates smoothly with tools like Spring. Then there's persistence, the ability to save data to disk so it survives restarts. And it boasts scalability too. You can use it in a single app or expand it across multiple computers, though that takes a bit more setup. Plus, it's highly customizable. You can really fine-tune how data is stored, eviction policies, things like that.
That makes a lot of sense for Java-centric applications, definitely. What about Redis then? What are its killer advantages?
Redis. Okay, its advantages. Number one is speed, pure and simple. Keeping data in memory means lightning fast access, perfect for apps needing instant responses. But tied with that is its versatile data handling. It supports complex type lists, rankings, maps, geospatial data even. This makes it great for a huge variety of tasks beyond simple caching. It's also highly scalable. It's designed to spread data across multiple servers easily, handling large, busy applications gracefully. Like cache, it also offers persistence, saving data to disk in different ways so you get speed and reliability. Plus, multi-language support is huge, making it great for diverse tech stacks, and it has those extra features like built-in messaging, PubSub, and scripting capabilities with Lua. It's more than just a cache.
A real powerhouse, you weren't kidding. And memcached. If it's simpler, what are its core strengths? Why choose it?
Memcached advantages really stem from its focus. It's very fast for simple data lookups because it's so lightweight. Less overhead. It's also incredibly simple to use, especially for beginners just needing basic caching. Less to learn, less to configure. It's highly scalable, just like Redis in that regard. You can easily spread data across multiple servers to handle high-traffic websites. Adding more nodes is straightforward. It also has multi-language support, similar to Redis, and it has very low resource use. It's efficient. Plus, it's proven. It's been used by massive websites like YouTube for years, so it's battle-tested technology for its specific use case.
Okay, here's where it gets really interesting, I think. The comparison. We know their strengths, but how do they stack up directly against each other? What are the key differences someone needs to keep in mind when choosing?
Yeah, this raises the important question, doesn't it? Because the choice often comes down to these specific needs and trade-offs. Let's break down how they differ. First, where they run. This is fundamental. Cache runs inside your Java application. It's part of the same program. Simpler for small projects, can be extended, but primarily in process. Redis, on the other hand, runs as a separate server you connect to. Great for apps spread across many machines, or different services needing shared cache. And Memcache also runs as a separate server, just like Redis, really designed for simplicity and speed in web app contexts.
Okay, so in-process versus external server. That's a big one. What about how they store the data?
Right, data storage. Cache stores data in memory or on disk. Gives you options for temporary or longer-term persistent storage. Redis primarily stores in memory for speed, but can save snapshots or logs to disk for backup and durability. It offers a balance. Memcached only stores data in memory, purely volatile. Fast, but data is gone if the server restarts. No persistence options at all.
Got it. Volatile versus persistent options and the kinds of data they handle.
Good point. Data types. Cache handles basic key-value pairs, but being Java native, it can store complex Java objects, though it might require some configuration, like serialization. Redis is the king here. It supports many complex data types natively: lists, sets, sorted sets, hashes, streams, making it super versatile for things like leaderboards, queues, real-time counters, memcached, just simple key-value pairs, strings, basically. It's limited to basic caching use cases because of this.
Okay, that's a clear differentiator. And scalability. You mentioned they all scale, but maybe differently.
Yes, scalability. Cache is good for single apps or small clusters. You can make it distributed, but it often requires extra setup, maybe third-party extensions like Pithoracademy. Less straightforward than the others for large scale. Redis was built for large-scale systems. It has built-in features like Redis Cluster for easily spreading data across many servers automatically. Memcached also scales very horizontally. You just add more servers. And the client libraries typically handle distributing keys across them using simple hashing methods. It's designed for distributed caching.
And what about just getting started? Ease of use.
Ease of use is interesting. Cache is generally easy for Java developers, especially within a Spring context. The complexity can ramp up a bit if you go for a complex distributed setups, though. Redis needs a bit more setup because it's a separate server you need to run and manage, but once it's running, its features are incredibly powerful, though there's a learning curve to master them all. Memcache is arguably the easiest to start with for simple caching. Its API is minimal, its purpose is clear, ideal for beginners needing a quick win.
Wow, okay. That's a lot to digest. So, boiling it down, what does this all mean? When should someone lean towards one over the others, specifically?
Right, the when to choose each summary. Choose cache if you're primarily in a Java project, especially using Spring or Hibernate. If you want caching tightly integrated within the app, or you absolutely need that disk persistence option without managing an external service. Choose Redis if your application needs fast handling of complex data types, tank rankings, real-time messaging, geospatial queries. Or if you're building a system that runs across multiple servers or microservices, potentially in different languages, needing a shared, robust cache. Its persistence is also a big plus for reliability. Choose Memcached if you need simple, high-speed caching for basic key-value data in a web application context, especially if you don't need the data to survive a server restart, and raw speed plus simplicity are your top priorities.
That clarifies things nicely. Now let's tie this directly into a practical context many listeners work in, the Spring Boot ecosystem. Our sources dive into how these tools work with Spring Boot. First, maybe just a quick refresher. What exactly is Spring Boot doing for developers, especially regarding something like caching?
Sure, Spring Boot is basically a tool, a framework that makes building Java applications, especially web apps or microservices, much easier. It simplifies setup and configuration dramatically. For caching specifically, Spring Boot provides this excellent abstraction layer. It helps make apps faster by letting you easily store frequently accessed data, user info, page content, whatever, so you don't keep hitting the database or other slow sources. The key is it makes adding caching simple, often just requiring annotations, not tons of boilerplate code.
Right. Taking the pain out of setup. So
Yeah.
how does cache, being so Java native, fit into a typical Spring Boot project? What's the experience like?
Cache is often seen as a top choice for Spring Boot precisely because it's Java native and works directly within your app. Integration is very smooth. You basically add the cache dependency to your project's build file, like Maven or Gradle. Maybe provide a simple cache configuration file, etcache.xml, and then tell Spring Boot to use it for caching via properties. Then you can just annotate your methods, say a service method that gets user data, with @cacheable. Spring Boot automatically handles storing and retrieving results from cache. For example, if a user's profile is requested often, cache keeps it ready in memory or on disk, so the app doesn't query the database every single time. You can also set rules easily like how long data stays cached or whether it spills to disk. It's great for Java developers wanting that simple, integrated solution. No separate server needed.
Okay, that sounds pretty straightforward. And Redis with Spring Boot, since it's an external server.
Right. Redis with Spring Boot involves connecting your app to that external Redis server. So first step is setting up the server itself, maybe locally for development, or often on a cloud service like AWS Elasticache or similar. Then you add the Spring Boot Data Redis Starter dependency, Spring Boot Starter Data Redis. You configure the connection details, host, port, maybe password, in your Spring Boot application.properties or application.ebml file. Once that connection is configured, Spring Boot's caching abstraction works beautifully again. You use the same at cacheable, at cache put, at cache evict annotations. Spring Data Redis handles talking to the Redis server and deserializing your Java objects. Redis is powerful here because it enables that shared cache across multiple instances of your Spring Boot app, or even across different microservices. Ideal for bigger distributed apps, requires more setup than cache initially, but offers more features for those distributed systems.
Makes sense. Lastly, Memcached and Spring Boot. You mentioned it's maybe less common or needs extra steps.
Yeah, Memcache can definitely be used with Spring Boot, but it's, let's say, less natively supported out of the box compared to cache or Redis. Spring Boot doesn't provide a dedicated starter for it in the same way, so you typically need to add a specific third-party Java client library. For Memcached, common ones are SpyMemcached or XMcached. You'd configure this client library as a Spring Bean and then configure Spring's caching abstraction cache manager to use this bean to interact with your running Memcached server. Once that plumbing is set up, again, you can use the standard Spring caching annotations like at cacheable. It's a perfectly valid choice if your Spring Boot app is part of a larger system that already uses Memcached extensively, or if you really prioritize that raw speed and simplicity for basic key value caching. But yeah, it requires a bit more manual configuration within Spring Boot itself.
Okay, we've explored the what and the how of using these with Spring Boot. Now let's really tackle the why. Why should a Spring Boot developer even bother implementing caching? What are the core benefits in that context?
Right, the why for Spring Boot. Well, Spring Boot apps, like any app, often deal with databases, external APIs, or maybe complex calculations that can become performance bottlenecks. Caching directly attacks these issues. The core benefits are faster apps, period. Storing frequently accessed data in fast memory means quicker responses for users, much better experience, reduced database load, This is huge. Fewer database queries save resources, reduce operational costs, and can prevent your database from becoming the bottleneck as you scale. Improved scalability. Caching allows your application instances to handle significantly more traffic without needing proportionally bigger, more expensive servers underneath. And, as we discussed, simplified development thanks to Spring Boot's caching abstractions. It makes adding this powerful optimization relatively easy compared to rolling your own solution.
Okay, the benefits are clear. So given all that, drilling down again,
Yeah.
why specifically choose EHCache for a Spring Boot project? What are the compelling reasons?
You choose EHCache for Spring Boot primarily for its easy integration and embedded nature. It just feels very natural within a Java Spring environment. Minimal setup, especially for developers already comfortable with Spring. There's no extra server to manage, deploy, or pay for separately, which simplifies operations, particularly for smaller projects or teams. And its flexible storage, memory or disk, gives you that option for persistence within the application itself. It's often the best fit for Java-centric projects that don't necessarily need complex distributed features or non-key value data types.
Makes sense. How about Redis for Spring Boot? When does that become the clear choice?
Redis becomes the go-to for Spring Boot when you're dealing with larger systems. Think applications spread across multiple servers, microservices architectures. Redis excels at providing that shared, highly available cache layer. Its versatility is another key reason. If your Spring Boot app needs to cache more than just simple objects, maybe lists for activity feeds, sorted sets for leaderboards, or use PubSub for simple messaging, Redis provides those features built in. It's also very reliable due to its persistence options, ensuring valuable cache data isn't lost on restarts. And it's ideal if your ecosystem involves multiple languages, as non-Java services can also connect to the same Redis instance used by your Spring Boot app.
Got it. Power and flexibility for distributed systems. And finally, memcached for Spring Boot. What's the strategic niche there?
Memcache for Spring Boot makes sense when simplicity and raw speed for basic caching are the absolute top priorities. It's super easy to set up for just key value storage, great for beginners or projects needing quick performance wins on simple data. It's particularly fast for web apps, perfect for caching things like HTML fragments or simple database results in high-traffic Spring Boot web applications. It scales well horizontally by just adding more servers fitting nicely into architectures designed for that pattern. And it might be the pragmatic choice if your existing systems or organization already heavily rely on Memcache providing consistency, the main caveat always being its lack of persistence.
Okay. So bringing it all together for our listener who's maybe trying to pick the right tool for their next Spring Boot project.
Yeah.
What's the final takeaway?
Yeah, the final takeaway boils down to matching the tool to the job. Pick EHCache if you're building a Java-focused Spring Boot app, want the simplest possible setup integrated right into your app, or need that easy disk persistence option. Pick Redis if your Spring Boot app needs to handle complex data structures, operates in a distributed environment across multiple servers or services, requires high availability, or needs to interact with non-Java components via a shared cache. Pick Memcached if you need an extremely lightweight, blazingly fast cache just for simple key value data in a web app context, and you're okay with the data being volatile, lost on restart. For Spring Boot beginners, EHCache is often the easiest entry point. Redis offers more power and flexibility for growing complex applications, and Memcache is the specialist for simple, high-speed web caching.
What an absolutely fantastic deep dive into the world of caching. We really navigated the ins and outs of EHCache, Redis, and Memcache, understanding their unique strengths, those critical trade-offs, and how they really play such a crucial role in making Spring Boot applications faster, more scalable, and, well, just more efficient overall.
Yeah, and if we connect this back to the bigger picture, understanding caching isn't just, about picking a technology from a list. It's about really thinking about how your application accesses data. It's about designing for performance and resilience from the start. It's a critical lever, truly, in managing the demands of modern data, modern applications.
Couldn't agree more. And that's our deep dive for today.
So maybe something to consider for your next project. How might analyzing your data's specific life cycle, how often does it change? How critical is it that it survives a restart? How many different parts of your system actually need to access it? How might thinking about that life cycle fundamentally shift your view on which caching solution becomes not just like a performance tweak, but a core strategic choice for the long-term health, maintainability, and even the innovation potential of your application?
Great question to ponder. Until next time, keep digging deeper.